When you're looking at polynomials, there's a lot of characteristics that are just pretty common to look for. And often those characteristics have a couple different notations that we typically use to write them in. So off to the side, we're going to draw a couple number lines, and then for each of these notations, I'm going to remind you guys how to write those specific numbers using the interval. So here, we're going to see on a number line that we're going from -3 to 2, and we are not including 3, but we are including 2. So in interval notation, this would be -3 to 2, and we'd put a parenthesis around -3 because we are not including it, and we put a bracket around 2 because we are including it. For set notation, I'm just going to use x. We're going to say the numbers are between -3 and 2, and we can equal 2, so I'm going to have an equal to sign. You should always have your, in both of these notations, you should always have your smaller number on the left side and your bigger number on the right side. And in the set notation, your inequality symbols will always go this direction. Alright, so that's just to be proper with math. Okay, the next one we're going to do is, and these are terribly drawn number lines, don't maybe draw them like this yourself, maybe do a better job if you ever have to. But here's this, we're saying it starts at 5 and it goes to the right, and it does not include 5. So for this one, with interval notation, we would do a parenthesis around 5. And then if we're saying that it goes to the right forever, then we're going to use an infinity symbol. And I know that it would, it would include infinity because it's dark there. But if I was to ask you, hey, where's infinity on a number line? You could not put your finger on it and show me where it is. As opposed to this one where I said, hey, where's 2 on the number line? You could put your finger on 2 and say that's where 2 is. So we put parentheses there because it's not a number that we can actually get to. The most common mistake that I see for this in set notation is a student would write it like this, and they'd put a 5 over here and an infinity over here, and you cannot do that. You don't use infinities in the set notation. So for this, we would just say x is greater than 5, and that's it. So if you put an infinity in this notation, yes, I know what you mean, but mathematically speaking, we don't write it like that. All right? And then last, we're going to go ahead and draw this one. So in interval notation, we would say negative infinity because it goes left forever, and 7 with a bracket. And then for set notation, we would say x is less than or equal to 7. Alright, so those are the notations. And as we fill out the rest of this sheet, I'll go ahead and kind of bounce back and forth between the two just so you can, get used to seeing each of them. Alright. So this first one here, we're going to go ahead and write whether the graph is increasing, decreasing, or constant. And constant might be kind of new to you, but I think you'll pick it up quickly. So what I find it easiest to do is I like to label these. I labeled the first one wrong. Decreasing, it's going down, and then we're increasing all along here. And we're decreasing right there. And here we are increasing, and we're decreasing, and we're increasing. So going down and up and down and up. Okay. So for this one, if I'm looking at the increasing intervals, the words increasing and decreasing imply the y coordinate, right? Because that's you're going up or down, so that's the y value. So when we're describing the intervals that is making the function increase and decrease, we are specifically asking what x values would be doing that. So the x value that we're starting with is -8, and it increases to -2. And the reason that I'm putting parentheses and not brackets is because at a single point you're not increasing or decreasing, it's just a point. A point can't possibly do one or the other. So -8 to -2, and then I put a u because I have multiple answers. And then next it's increasing from 0 to 2. And then it's increasing from 5 forever, so we're going to say 5 to infinity. For decreasing, we have an arrow to -8, so negative infinity to -8. And then we've got -2 to 0. And then we've got 2 to 5. And this graph, it has nothing for constant. There's no interval where it's just constant. It's not increasing or decreasing. Okay. Now on this graph, we do have all 3 situations happening. So right here, the graph is not increasing or decreasing. This is where you would say it's constant. Then right here, it's decreasing all the way down here, and then it's constant. And then it increases for a little bit. So here, and I'll go ahead and do set notation on this one, this graph is increasing from when the x value is 2 until where the x value is 3. So I'm going to say as long as x is between 2 and 3, you are increasing. For decreasing, we're using an x value of -1 to an x value of 1. So if x is between -1 and 1, you are decreasing. And then your constant from -3 to -1, and from +1 to +2. All right, now for these notes I gave you a nice looking graph that you already had. Like on this one you can see the domain originally was limited. I cut things off here. Here you have arrows so it goes on forever. So one thing that you'll want to keep in mind is the interval of the overall graph. So the interval for this graph was -infinity to infinity, included everything. But the interval for this graph was from -3 to +3. And then we can do equal to for intervals. So just be careful to watch for that. All right, because this graph could have, if it, don't draw this, but it could have continued and like gone over and had another constant part and then dipped down. And these parts would be like, yeah, it's increasing here and it's constant there and it's decreasing there. But if they specified an only answer for this interval, then you would not be able to write those extra answers in. So be careful to watch for that. Okay. Next, we're going to go ahead and look at extrema of the graph. So we have local extrema and we have absolute extrema. So local is also known as relative. That might be the vocabulary that you have heard before. So relative extrema. So this is when you have a minimum or a maximum of a function over a small interval. So we're not talking the whole graph, we're just talking for a little piece. So if you look at this picture, this right here would be a local max, because in that little interval it's a high point. This would be a local min. This part right here would be a local max. This right here would be a local min. This would be a local max. All right, so those are all local or relative because they're kind of maximums, but they're not necessarily the max for the whole graph, or they're kind of minimums, but not necessarily the min for the whole graph. Okay. The absolute maximum or minimum is the minimum or the maximum of all of the range values. So of all of the y values represented, it's the absolute highest point or the absolute lowest point. So here we can see that this local max right here is also an absolute max. It is literally the highest point of the graph. But if you try to find the very lowest point of the graph, you can see we've got these arrows that just go down forever. And here, we don't call arrows absolute mins because they go on forever. So for this specific graph, we would say no absolute min. No, and you can write out the words if it makes more sense later when you look at your notes. So no absolute min for this graph because it has arrows that go down forever. All right. Okay, so in this picture over here, we have a local maximum right here at this point. So that's at 0, 1. We have a local minimum at this point right here and this point over here. So that's 2, 0. And -3, -3. We have an absolute maximum at the point 4,2. That's right here. It's our very highest point. And we have an absolute minimum down here. Okay. Now, a side note, we're going to say endpoints cannot be relative or local extrema. So if you recall, the definition of that was that it's over a small interval. Well, if you're talking about just the end, you're not talking about an interval. So if I take away the rest of the graph and I just look at this, it doesn't look like a maximum. It doesn't look like it's going up and coming down. So endpoints are not allowed to be relative extrema. They have to be absolute. Or they could be nothing, I guess. Like this one, it's an endpoint, but it's nothing. So. Okay. So here another example. If we look on the graph and you look for a local maximum, you'll just see that there is none. We don't have anything that looks kind of like a mountaintop or anything. Here we have a local minimum, and that's at -1, -1. For an absolute maximum, it looks like it would be up here, but see how that point is not included, so we're actually going to say none. That point is not actually there, so there isn't one. And then the absolute minimum is -1, -1. All right. So opened endpoints cannot be any type of extrema. They can't be local, relative, because that's the same. I almost spelled extrema wrong. Extrema or absolute extrema. They can't be anything.